Right, I'm recording now. Right, good evening, boys and girls. Good evening, everyone. Right, today we want to finalize and consolidate the topic on civil drawing. Like I said from the beginning, I will have 2 tasks for each topic that I'm going to touch. So far, we completed the question number 4 for civil drawing for 2018. So this time, I'm going to look at the 2019 one, right? And I'm going to look at question 4 so that we consolidate our understanding in terms of that question. We have got all the ingredients that we require in terms of answering that particular question, okay? So I'm going to go straight into the business of the day in terms of what is it that we would look at. Right, today I'm going to start differently. I'm going to start with the detailed section. The reason being that in terms of the work with regards to question number 4, you'd find that in terms of completion of the floor plan, it's basically the same thing. And in terms of elevation, the one that we did yesterday, right, when we do it again, you'll find that it will basically be the same. But there's one particular detail that we did not touch with regards to the section, right? That is about the window. So I'm going to focus on this one, the detailed section today, so that we show you how you represent the window in section. So boys and girls, I want you to pay special attention today so that we are able to go through this together and fully. Please don't forget my words. These are very important words. They are not mine, like I said. Right, they are words of timeless value. Like I told you, they are extracted from a Chinese proverb. I hear and I forget, I see and I remember, I do and I understand. Like I've always said, right, for technology and for practical subjects, you need to be practical in order to be able to understand what you are doing. So I want you to understand, I want you to do it, I want you to apply all the concepts that we are going to do and that I'm going to demonstrate today so that you'll be able to apply them as we go on. Thank you. Good luck. Like I said, right, we are going to look at the 29 paper, that is last year's paper, in terms of question number 4. Right, help me to go through this together so that you understand and you'll be able to confidently answer this question on your own. All right, so this is the question number, last year's paper, okay? This is how it would look like from the outside. I just want you to have a feel of it, okay? All right, then from there, we have got this paper now. This is the information paper. So when you get to the exam, please, you need to settle down, you need to be relaxed, right? And apply all the techniques that we talk about in our lessons right now. Right, with regards to that, we are going to focus mainly, right, on a detailed section. This is our detailed section in terms of the information that is required. But I'm not going to read through all the information because it's similar to what we have done so far, okay? But you'd find that in terms of how it is presented, it might be slightly different, okay? Right, and I'm also going to check with you the rubric, right? We have got, with regards to the rubric, we have got the roof detail, we have got the foundation, wall, and window that we need to insert and show, right? We also need to show the position of the bath and how it is represented. We also need to show the labels, right, for 1.5 marks. So we shall see which labels are critical in terms of our section and how do we present the labels, where are we going to show the critical labels and so forth. So I want us to start, right? I'm going to drag this, right? You are given here, right? This is the footing, right? That information is given, so you are not going to get any marks. The only thing that you would get if you are given this, right? Some of you would quickly go and do this, okay? Right, I'm just showing you some of the techniques that you can employ as you are thinking about how to answer the question and so forth. You can go on. You know that the footing is basically made of concrete, so small little circles, small little triangles, right? Then you know that automatically in terms of hatching, say for the substructure, you already have got half a mark. Then once we have done that, right, if we look at the information that is there, we know that from here to there, it's 600, which is the same as that. Right, from our previous calculations, we know if we are using scale 1:20, basically that's 30, okay? Right. By now, you should know I don't want you to measure, so I'm going to miter faintly, right, like that. Faintly, like that. What is the purpose of doing this? This is basically to find the midpoint, right, so that we are able to find the center, okay? Right, then from there, you draw a faint vertical line like this. Right, so if you measure from here to there, you'd find it's 15. From here to there, it's also 15, okay? Right, then you look at the information with regards to that, you find that the thickness of that wall is 200, then to scale, basically that's 10, okay? Right, you can either make use of a scale rule or just an ordinary ruler, right, to measure, which is 5 this side and 5 that side, okay? Then from there, you take your set square, you draw a vertical line all the way up, right, and all the way up. These are construction lines, so they have to be as faint as possible, but at the same time, they should be visible in terms of someone who is looking at your work. Right? Then from there, you need to define the height in terms of the natural ground level, in this case, which is 300. So 300 divided by, right, I can just make use of a scale rule, right? In this case, I look for scale 1:20, right, which is here. Right, okay, so I will count, that's 1, 2, and 3. By calculation, that's about 15 millimeters. Then you draw a faint horizontal line all the way to the break line. Right, I explained the part where with regards to the break line, if you're not given that, but you want to insert it, right, you can either measure from the wall to the end point of the elliptical part, or from here to there, which is the ridge line. But because we are not given this information, so you measure from here to there. That is the same distance that you'd find from here to there. This distance from here to there multiplied by 50 divided by 20, okay? I'm just recapping, like I said, the main purpose of doing this is to basically consolidate our understanding with regards to a particular question and a particular topic, okay? Right. You can, once you have drawn this line, you can even outline this, make it as dark as possible, but also skip the wall. This is the underside of the hard core, okay? You go back to the information paper, you look at it, right? So from here to the underside of the slab is 350, okay? Right, 350, we are using scale 1:1. 1:20, so we may not get the right answer there because it's in divisions of 20. So 350 divided by 20, okay? You are going to get 17.5. That 17.5, you now measure, right? You now measure from here. This is 15, 16, 17, 17.5. You measure from here. Then you draw a faint line, right? So this part from here to there, that part would constitute what we refer to as the hard core, okay? Right, and we check with regards to the information. We have got the information from here to there, which is 100. That is the height of the slab. 100 divided by 20, by now, mathematically, we know it is 5 millimeters. So we are going to measure from here to there 5 millimeters and mark our point. Then we draw a faint line like that. Right, boys and girls, like I said, right, if you are looking at a building, you look at the substructure, you look at the walls, you look at the roof. Those are the three main components of what we refer to as a building, okay? So in terms of the substructure, from here to the lower part of the footing is what we refer to as the substructure. So I'm going to outline this part from here to there, right, all the way, right, from here to there, all the way, right? Then close this part. Remember, the slab is halfway embedded into the wall, so you close that part like that. Then you can even outline here, from here to there, like that. And you can even take this one up, like that. I just want you to appreciate in terms of the components that I talked about with regards to the building, right? So from here up to there, that is our substructure. But by now, you know that the moment you have got the slab, you extend this one outward like that. And what is that representing? That is the DPC, okay? DPC, the dam proof course, right? And when you get here, you can even show, right? That is the NGL. These are details that you can provide as you go, okay? All right, so let's make sure that when we look at question number 4, we are excited to answer it. We are happy to answer it because all the information that we want with regards to the exercise are basically there, all right? Now, this is concrete, this is also concrete, so I'm going to H. All right, I know in terms of our rubric, the hatching is at the end, but like I said, sometimes because of pressure of the exams, you may end up forgetting to hatch. So at the moment you get the opportunity and you are done with a certain component, you conclude that. This from here to there constitute what we refer to as the hard core, like I explained last time. So I'm going to hatch like that. Like that. So that is the hatching of the hard core, okay? All right, you are also going to hatch the unfinished, undisturbed earth, right? I'm not going to dwell on this topic today. I think I did explain that last time, right? That is the undisturbed earth. You may not need to do quite a lot. Just show that you understand this part and that part is ground that has not been disturbed. I explained a lot about this from here to there and from here to there, where we talked about the backfilling. Sometimes you'd find that they may give you marks for showing this one as well at the bottom. That's fine. That is also undisturbed earth, okay? So you have got the NGL, you have got the DPC, you have got the hatching with regards to the substructure. Then you should be excited. All these are marks, okay? Right, you have done that. The next thing that you need to do is to measure from here to the wall plate level, which is 2,600, okay? 2,600, that is easy to measure using a scale. So I'm going to check for my scale. All right. Please make sure you are using the appropriate scale. Right. So from number 6 to number 5, that's 1 meter, that's 2 meters, that's 2.5, that's 2.5, that's 2.6, like that. Okay. Just to make everyone understand, I'm going to do the calculation with regards to that. Sorry, that's not in the picture. Right, so I measured from here to the 2,600. This is the height that we refer to as the wall plate level, okay? Right, I'm going to do that. All right, from here, that's 1 meter, that's 2 meters, that's 2.5, that's 2.6, okay? That's what you do if you are using a scale. If you are using an ordinary ruler, that's 2,600 divided by 20. You'll find that we need 130, and if we check, this should give us also 130 in terms of the distance from here to there, which is exactly that, okay? 130, okay? So that's fine. So once you have gotten to this point, the next thing that you want to do now is to start with the issue of the roof, okay? Right. You go to this page, look at the information, the schematic diagram of a roof truss for roof A. So if we check with regards to the information that we have got roof A, which is this part. We also have got, it's not defined in terms of roof B and so forth. So the schematic diagram in terms of roof A, okay? So we have got roof A, which is directed there. Schematic, like I said last time, is basically a line diagram that is representing something. So let's not complicate that one. It's just a line diagram, the skeletal representation of something, okay? So the pitch here is 30 degrees. Remember, the pitch is the slope of the roof. 115 by 40 roof trusses on 115 by 40 wall plates, okay? Right. Now, we want to start with this part, which is the wall plate, okay? Right. If you do your calculations, you'll find that 115 divided by 20, but we are going to get 5.75. That 5.75 is closer to 6 millimeters, so I would want us to measure 6 millimeters from here to there, right? I'm trying to be as accurate as possible in terms of our presentation, right? Then you draw a faint vertical line like that, right? So from here to there, that's the length of the wall plate, and the height is 40 millimeters. 40 millimeters, that's 2 millimeters, okay? So I'm going to measure 2 millimeters. Like that. Then you draw a faint horizontal line like that. So here we now have got what we refer to as the profile of our wall plate. So I'm going to outline this, right? Like that. Then outline this one as well, from here to there, right? So the wall plate is in position, but it's not fully defined. To fully define this one, you need to draw two diagonals, not as thick as an outline, like this. Like that. Boys and girls, right, with experience, as you would practice in terms of this exercise, you would know that the moment you draw a wall plate, right, if there's no other wall in sight, as we can see right here, right, there's this from here to there, there's no other wall, okay? So you can draw, outline this, right? That is basically the line that we refer to as the ceiling board, okay? Right, if you check the size of the ceiling board to scale, right, it's 8 millimeters. 8 millimeters divided by 20 is too small to measure. So basically you would draw a line like that, okay? right? And again, with the experience, the moment you have got this, the wall plate and the line in also in line with the edge of the wall plate, this can also be outlined, right? This is where we are able to fit the branderings, okay? Right, I shall show you again like we did last time, but I just want to give you, right, hints as to how you can be fast in terms of completing your exam, okay? Right, from there, we now want to define the pitch line. We are told that the pitch is 30 degrees, so you take your set square, right? At 30 degrees, you draw a line like this. This line should touch this point, okay? Right, that is the pitch line, right? Now, you'd find that in some cases, if we check under our rubric, like I've explained last time, this is where the mark allocation would be awarded in terms of the roof, okay? Mark allocation for section of the roof, okay? The pitch itself, just the pitch line like that, you'll get a mark, okay? All right, again, it depends with the marking scheme and the memo itself, how the marks are allocated, but definitely you'll get a mark for drawing this line, which is the pitch line, okay? Right, the next thing that you would want to do, right, as you can see from this plan, okay, there is the distance from here to there. This line, the dotted line here, it's basically representing the ridge line, okay? Right, what it means is that it's double pitched, it's rising up and it would fall on the other side. So what I want you to do, I want you to measure the distance from here to there, okay? You measure that distance so that we get to the pitch line. Right, let me just check. Right, I'm getting 24. Right, 24, if I multiply 24 multiplied by 50, because the plan is drawn to scale, 1:50 is equal to that, divided now by 20, we are going to get 60, okay? So the 60, you can even measure from here to there, okay? That's your 60, right? Then you draw a faint vertical line like that, right? Then you turn, right? Like this, right? The pitch line is now going in the opposite, in the other direction, okay? Right. The next thing that we want to do now is to define the issue with regards to the rafter itself. We have done this and it's partly cut here. So this part, and it's cut by the break line here. So we want to define that one, which we said is roughly 6 millimeters, right? In terms of the size of the rafter, right? You draw any line which is perpendicular anyway, okay? If this is 30, right, complemented by 60, you'd find that we create an angle of 90 degrees. Right, so I'm going to do this, measure 6 millimeters, like that. Measure 6 millimeters, right, like that. So that is the size of the rafter, right? Then when it comes here, you do the same thing, you turn like that. So basically you may extend this one slightly, right, in order to accommodate your section, okay? Right, there is nothing that is going to change with regards to this, so I can outline from here to there, right? And I can also outline from here to there, that is the rafter, like that. Right, for now, this is what I'm going to do, but it's not complete, right? I can outline up to the wall point just to give you an insight of what we are doing, but I'm going to extend it in order to accommodate the overhang, okay? Right. I just want to give you a picture, okay? Then from here to there, right, you would need to measure 6 millimeters again, which is this part, which we talked about as being the tie beam. Then we also need to define this part, which is the king post. Relate this one to grade 8 and 9 technology. We would always talk about the roof, the truss, and so forth. The members of the truss. This is now applicable now in grade 12 metric, okay? So you'll see this one is the rafter, this one is the king post, this one is the tie beam, okay? So we are going to draw all these members to scale. Remember, this is 115 in terms of the size. This is also 115 in terms of the size. This is also 115 in terms of the size. So I'm going to measure from here to there. That 6 millimeters that I talked about earlier on. Then from there, I can draw all the way like that. Once I've done this, you can outline like that. Now we have got the rafter in position. We have got the tie beam in position. This space, like I said, is going to be occupied by the branderings, where the ceiling is fixed, right? Right. Here, if I say it's 6 millimeters, I'm going to measure 3 millimeters either side, 3 millimeters this side, and 3 millimeters that side, right? And also draw going up, right? Like this, like that. Right. Sometimes you may be asked to show the connection between this and that by way of the gusset or the gang nails, okay? Right, but if that information is not required, do not waste your time on that. Right, this is enough in terms of the representation of the truss, but let's go to this side. It's not complete, right? Just closer to this, I can just draw a line anyway, okay? Right, go back to the information paper and check. So what I've done, right, I've defined the pitch, right? I have defined the roof truss and the wall plate. I want you to do the same thing, just tick nicely and slightly, just to show that you have answered that particular part of the question, okay? Then 300 roof overhang to end of roof truss. So this is where now you would require, right, you will require 300, right, 300 by now, we know it's 15, so you measure 15, you can measure that one with a scale rule, right? Then you take this one vertically like that. So the distance from here to there, that is the overhang with regards to the rafter. So I'm going to outline this like that and take my 30 degrees set square, then extend the pitch line like that, like that. Right? So now in terms of the truss, without the palings, without other details, this is what we buy from the hardware, okay? Right, and we now want to finalize that, right? In terms of the other details that we require, we go back to the information paper where you can see, right, from here, that is the first center of the paling to that point, to that point. So how many palings do we have? We have got 3 palings which are equispaced, basically meaning equally spaced, okay? Right, so 900 to scale, right? I just want to check, 900 divided by 20, that's 45. So we want to measure, mark a point closer to the end, right? This is trial and error, right? Mark a point, check, right? If I do this, this is my first sender, then 45, that's my second sender, then another 45, right? Which would come here, like that. That's my third sender. So I've got my first, second, and third. The moment you get to that, you now draw lines perpendicular to that, right? Like this, faintly, like that, faintly, like that, right? So sender from here to there, that's 45, which is representing 900. From here to there, that's another 45, representing 900, okay? Then if you check with regards to the height of the paling, right? Let's go there. Right. 200 millimeter fiber cement roof sheeting on 75 by 50 millimeter palings at 900 center to center. C stroke C is basically referring to from one center to the other. Right? So from here, we need 75. We need 75, right? 75 from here to there going up, and would measure from here to there 50, which is 25 and 25, 25 and 25. Right, let's start with the 75. Right, 75 divided by 20, right, we'll get 3.75. That is closer to 4 millimeters. So let's just make use of 4 millimeters like this. Right, again, you take your 30 degrees set square. Right, you do this. Right, and you come this side, you do this one as well, okay? All right, so you have got this line, right? It's representing the underside of the roofing cover, but at the same time, the height of the palings. Right, then the next thing is to measure the 50, right? Which you are going to split either side, and that, which we know that is 75 by 50. 50 divided by 20, you are going to get 2.5. So I want to make your life easier. Just measure 1 millimeter either side, 1 millimeter there, and 1 millimeter there, okay? 1 millimeter there, and 1 millimeter there. 1 millimeter, and 1 millimeter, like that. Right, again, you draw this at 60 degrees. You project like this, project like that. Like that. Then you can outline this from here to there, from here to there. Like that. Now, you see this center here, we can easily transfer it to the other side. So you can transfer this one, you mark a point like this, and again, you draw at 60 degrees, like that. You also measure either side 1 millimeter, 1 millimeter. So I'm going to do that. 1 millimeter and 1 millimeter like that. Then take this one up and take this one. Then you can outline this. You can outline that. So there is a paling this side and also the paling on 3 palings on the other side. Right, let me just, but it's not necessary. Let me measure the size of the roofing cover. Right, we know it's how many millimeters? Right, it's 20 millimeters. Basically, that would give us 1 millimeter, okay? So we need 1 millimeter at the top. So 1 millimeter to scale, which is 20, like that. Then you draw a faint line, firstly, right, like this. Then you take it to the other side. Unfortunately, it's going out a bit. Right, like that, okay? Right, so this is the roofing cover. And we know that in terms of the roofing cover, they should leave a small little gap at the top and a small little gap at the top like this. That is where the roof ridge capping would come in, okay? So you can outline this part and also do the same, this side, you outline from here to there. This side, there's nothing that would stop us, right? We can extend this one because it's going to be stopped by the break line, right? So on the right-hand side, right, in terms of the roofing cover, it's in position now. Then you can also define the paling, right, like this. Those cross, that's wood that has been cut, right, like that. You do the same here, like that. You do the same, right? The conventional representation of a paling, you do the same this side. I'm going to draw the line at the top, so I'm not worried about closing at the top at this point. You do this like that. So you have got, this is the first paling, the second, the third, and the fourth on the other side. Right, so you have got the palings in position. Let me just outline up to the rafter end, right? But we are going to extend this, but I just want you to have a picture as to how the roofing material is laid. And normally it's nailed on the palings like that, okay? We are still going to extend this by looking at other details and so forth, okay? Right. The next thing that you want to do, right? We have done this. We have 20mm fiber cement roof, roofing cover on 75 by 50 palings at 900 center to center. This part we did, okay? We also defined the roof overhang. I ticked that. The next thing that we want to look at is the fascia board 300 by 20mm with 150 by 150 gutters on all sides, okay? Right, let's start with the fascia board. Right, this is the end of the rafter, right? The thickness of the fascia board is 20mm, which would translate to 1mm. So you need to measure 1mm from here to there, like that. Right, measuring from the end of the rafter. Then you draw a faint vertical line like this. Right, the moment this vertical line hits the underside of the roofing material, right, then you turn it like this. You can actually outline this part like that. Then you now measure from here to there 300, which we know by now it's 15mm. So I want you to measure from here to there 15mm. I'm going to do that, which is this point. Then you draw a faint horizontal line like that. You can also close this. Boys and girls, we now have got our fascia board in position. Like that. That is our fascia board in position, okay? Remember what I said last time? The fascia board is there to protect the end of the truss, but at the same time, it is there for aesthetics purposes, beautifying the outlook of the building itself, okay? It would look nice when the fascia board is fixed. All right, then from there, you now want to define the size of the gutter in terms of the part that collects water. In this case, the depth of the gutter as well as the width of the gutter is basically the same. So it's 150 by 150. Of course, the gutter is fixed to the fascia board, right? I'm going to measure 150. Right, remember everything is to scale divided by 20. Right, you have got 7.5. So I'm going to measure from here, that's 7, that's 7.5, okay? Right, put a mark there, then a faint vertical line like that. Right, once you have defined this from here to there, that's the extent of the gutter. Now you know, right, that water should be collected from the roof, then into the gutter. You now have got the idea where to stop the roofing material, okay? Remember we said we are not taking it all the way, right? But I want to take it in such a way that it will be able to bring water into the gutter. This is what we have done, okay? Right, from here to there, that's the gutter, so the water would be dropped into the gutter, okay? Right, the other information, right, so here I've got 300 by 20 fascia boards, 300 by 20 fascia board with 150. This part we are done, okay? Right, let us look at the 300 by 30 by 5 millimeter batch board on gable ends, 40 millimeters past the gutters, okay? So you have got this line, which is representing the position of the gutter. I haven't defined the gutter fully as yet, okay? Because I'm still waiting to define the end point of the batch board. So we need 40 millimeters, okay? Beyond the gutter. 40 millimeters by all accounts would be 2 millimeters. So I'm going to extend this one, draw, measure from here to there, 2 millimeters, then draw a faint line going upwards like that. Now, basically what it means is that the batch board, part of it, if they say by 30, part of the 30 millimeter, let me just show you if we have got this part, right? It is going to be hooked on top of the roofing material, right? On the gable end. So you won't be able to see the roofing material in terms of the end of the cover itself, right? But the thickness from here to there, it's 5, right? So on top of the roofing cover, we need to consider the 5 millimeter thickness, but as you can see, 5 divided by 20 is too small, 0.25. We cannot measure that. So what we are going to do, we are going to extend from here to this point, okay? Right, in terms of the batch board, this is how we do it. You extend that one there. Then you measure from here to there, 300, which again, by now we know it's 15 millimeters. So I'm going to measure 15 millimeters up to there, okay? Right, once you have measured that, you draw parallel to the pitch line like this, like that. I'm not going to outline this for now, right? From here to there, this can be outlined. There's nothing that is going to change, like that, okay? Right, so from here to there, that's the height of the batch board, which is 300. Let me just verify. Right, which is 15, which is fine. Then you would draw a line like that, okay? Right, once you have done that, the next thing, right, you project a line from here. Remember, the gutter should not be seen, right? Where it hits this line in terms of the gutter, you have got this one, right? We know that the gutter is 150 by 150, so I can easily miter there, right? So that the distance from here to there is also equal to that one. Then you take this one like that. These are some of the techniques that you can employ in order to be fast in terms of your work, right? So I'm going to take this one up like that, right? Again, the other thing that you need to consider, if you are not given the batch board, okay, you can even draw a line from here all the way, right? Then where it meets this 150 line, which is our 7.5, then this bottom one, that's where you would start your gutter from, okay? So the positioning of the gutter, it depends with the situation. So from here to there, 7.5, from here to there, 7.5, which is 150 and 150. Then once you've done that, you can go back and outline now. Right, you outline from here to there and from here to there, right? Not beyond the wall, because you won't be able to see. Now, so you now have got from here to there, all the way at the top, like I said, there should be a 5 millimeter thickness, right? All the way at the top like that, okay? Right, which is representing the fascia board is sitting on top of the roofing cover. Boys and girls, I'm sure you are following and you are liking what we are doing right now, okay? All right, so the next thing that you want to do, right, at the end here, okay? Right, this is the end of the wall. I'm just going to tamper with this one slightly so that you are able to see, okay? All right, this is the edge of the wall. This is the edge of the wall. I talked about this and said that is what we refer to as the beam filling, right, like that, okay? Right, so That is the extended part of the wall, but you are not going to raise it all the way with the thickness of 200. It's basically going to be in line with the end of the wall plate, okay? Then the next thing that we want also to look at, if you check with regards to the information that we have got this part, which is our roof cap and ridge cover, okay? Right? I'm going to measure from here to there 150, from here to there 150, okay? Representing the total span to be 300, okay? Right? We know that 150, according to our calculations area on, is 7.5. So I'm going to measure 7.5, 7.5 this side, and 7.5 this side, okay? Then you take this up, you take this one up like this, you take also this one up like this. Right, where it meets the outside line here, okay? Right, you draw like that at 60 degrees relative to that 30-degree pitch line. Right, then you measure from here to there 1 millimeter, which is the thickness of the roofing cover. 1 millimeter, we know it's 20 millimeters, so you are going to measure 1 millimeter, right, like this. Right. Then you take it all the way to the ridge point, then you do the same like that, right? It would come here, okay? Right? Then you can outline this like that. Let me just extend like that. Like that. You can also outline this one all the way like that. And this one is already there. Then you close like this. And you also close this side like that. Right, boys and girls, that is how we insert the roof cap, okay? Right, so that small little gap which was left at the top is now covered with the ridge cap. Right, okay? Right, we are done with that part. Let us go and check any other information that we require. Right, 300 by 30 by 5 batch boards on, right, this we have done, okay? Right, what is left now is 8 millimeter ceiling board on 40 by 40 millimeter brandering strips at 600 center to center, okay? Right, like I said, we have already defined the space for the branderings, okay? If you are not given the starting position, what I would urge you to do, just leave a gap like that, right? Then you miter like this. So automatically the distance from here to there is 40, okay? If you miter again like that, and you miter again like that, then close this end, right? You have got your first brandering. Remember, when we are talking about a brandering, it's wood that has been cut in form of squares. If it is for the ceiling, it's called the brandering. If it is for the roof, like for tiles, it's called the battens. So just take note of that. So that is our first brandering, okay? Right, so then we drop from this point going downwards like that. We also draw a line from here all the way like that. Just halfway, sorry about this, halfway like this, okay? Right, so from here we need to measure 600 to scale, that would be 300, okay? That would be 30, sorry. Right, we now measure from here to there, 30. That is our second center. We measure again 30, like that. That is our third center. So we have got the first, second, and third center. Then we take this one up. We take this one up. Right, very simple exercise. Then you take your 45 degrees set square through that center. You miter like that. Let me just verify if this is the right thing. Right, yes. it is. You come here, you do that. Then you change the side, you miter again like this, you miter again like this. Then you close the square from here, from there, close this, and close this. Boys and girls, you have got your brandering in position, like that. The only thing that is left now, just to define these crossings like that, like that. You do the same this side, like this, like that. There you go. You have got your face, number 1, number 2, number 3. So what they will be looking at is to check, right? Did you manage to show the conventional representation of a brandering? Yes. Do we have the correct sender to sender? Yes, okay? And that way you get all your marks. Right, we are done with the roof. I can even confidently also tick this part and say, oh, right, in terms of the information with regards to the roof. And how many marks do you expect for the roof? Let's just go to the rubric and check. Right, all in all, right, in terms of the roof, right, it's 16 marks out of 34, okay, which is basically half the allocation in terms of the detailed section. So the roof is a very important part of the section. So you need to understand that, and you need to know how to represent all the elements of the roof, right, with regards to the section. The next thing that we want to look at is the section through a window, okay? We know that if we check here, 200 by 75 millimeter lintels above all window openings, okay? Right, if you check on our cutting plane, we are going to cut through window 2, right? The next thing that you need to check is to see how that window 2 would look like in terms of the height. We know that from here to there it's, right, the window is 900 in terms of the height. So we need to factor that. All right, okay. So this is what you are going to do, right? First of all, you measure the height, which we refer to as the window level, okay? Right, the window level is basically also given as the door height, okay? Right, so the window level, this height is the same as that one. These points are in line. It's given as 2050, okay? So you come here with your calculator, 20 and 50 divided by 20, you are going to get 102.5, right? And this is measured from the finished floor level. The finished floor level is this, okay? Right, 102.5. Let me just take this one up. Right, this is 100, 101, 102.5. Please be precise in terms of your measurements. Right, then you draw a faint horizontal line like that. Right, automatically, the moment you have drawn this line, you check for the size of the lintel, which is given here, 200, which means it's from here to there, okay? Right, by 75, you take your calculator, 75 divided by 20, we said is 3.5, which is roughly 3.75, which is roughly 4 millimeters. You measure 4 millimeters from here to there, right? Then you take, right, like that. Right, there's nothing that would stop you from outlining here. Remember, you'll be under a lot of pressure, right, in terms of time. Right, you don't want to spend more than 1.5 hours on this question, otherwise you will deprive other questions of attention as well. Right, you have got this. Now I can outline from here to there, all the way. I'm now confident, right, outline from here to there to the wall plate level. Right, you have got this. This is concrete, so you would do this, small little circles, small little triangles, like that. That is the conventional representation in terms of the hatching for concrete. Right. Once you have done that, you now measure the height of the window, right? The height of the window. We know it's 900. So 900 is measured from here going downwards like that. So you say 900 divided by 20, you will get 45, right? 900 divided by 20, you get 45, okay? So you would measure from here to this point, right? That would give you the height of the window, okay? Right, the other information that we are given is that the notes, door, as well as the window. Normally you'd find that all the frames, okay? If it's not given, just take it to be what? To be 50 millimeters, okay? Right, so in terms of the frame, that is the thickness of the frame, right? The window sash, right? You'd find that if we are talking about 50 divided by 20, we got 2.5, okay? Right. Naturally, you would want to split that so that it is positioned right in the middle. So you measure 1 millimeter this side and 1 millimeter that side, okay? You take this one up like this. Sorry about that. Take this one up like that. Then this one also up like that. So you now have got basically the position of the window in terms of the section. This one you can even outline from here to there. Right. You take your 30 degrees set square. You take your 30 degrees set square. You do this, right? You measure from here to there the size of the window sill. Right. Let's look if we are given that measurement. Here you go. Right. At this point, it says all frames 15 millimeters thick, that we have already defined, 180 by 20, okay? Right, so we are going to measure from here to there 180 divided by 20, which would give us 9 millimeters. So I want you to measure 9, right? You measure 9 millimeters from here to there. Once you have measured that, you draw at 60 degrees. Then 20, we know 20 millimeters is 1 millimeter. So you measure from here to there, 1 millimeter like that. Then you take this one back, okay? Then at the start, you bring this one like that. You can even outline this part and outline this part, okay? Right, then you close and close that part, okay? There you go. You have got the window sill in position. Just to define this one, you draw a horizontal. At the connection point between the sill and the wall, you draw a line. Then you draw at the corner here, right? At the corner of the sill, you also draw a line like that. That would take you up to this level, okay? Then this one, this part is just filled with mortar, okay? It's not concrete, but it's mortar for bonding purposes, okay? Right? So you have got this part which is filled such that with mortar, such that it's going to bond with the wall, okay? Right. The next thing that you would need to do now, you bring this one down, not as thick as an outline, right? You do the same thing, not as thick as an outline. Right, but the moment you go past this point, you can outline. This is the wall, okay? The same applies with this one. You can outline here. That's the wall. Right, so that is how we treat the section through the window, okay? Boys and girls, I'm hoping you are following this. The next thing that we want to look at, right? We have done this, right? The next thing that we want to look at as we cut this, we have got the position of the bathtub, right? If we check even on our rubric, right, that is required as well, right? You have got 1,700 by 430, okay? So you come here from here to there, 1,700. You do this 1,700 divided by 200 by 20, sorry. which would give you 85, right? So you measure. Right, just 1,700 divided by 20, we'll get 85, okay? As you can see, the 85, it's outside. So I'm not going to worry so much in terms of that part, right? But let me measure it. So where's my 85? It's here, right? But it's outside. It's outside the area that we are able to see. And what is the height? The height would be 430 divided by 20, which would give me 21 and a half, right? So you measure 21 and a half, which is from here to there, right? Then you draw a line like this, right? As you can see, if you check properly, you'll find that at this point, there's an angle. Roughly, it's about 60 degrees. So you can even bring this one down like this, right? Like that, okay? Right, because we are not going to see anything beyond this point, then you can define. You don't worry about the complicated details in terms of the bathtub. This is enough, okay? So in front of you, you'll be able to see this detail, which we refer to as the bathtub. Last but not least, with regards to today's work, I'm going to hatch the walls so that we know we are done with this particular aspect. So I'm going to hatch. I'll start with the beam filling, right? Like that. Skip this. Your eye should also be fixed to the clock so that you are able to finish your work. But I needed to explain and consolidate your understanding with regards to this. So if we look at it fully, right, you'll find that we have got something like this. There you go. We have got NGL here, we've got DPC there, then the other DPC is located on the underside of the window sill, okay? So you have got this 1, 2, and 3. Those are the 3 main labels that you require in terms of your section. Boys and girls, right? With regards to civil, tomorrow I'm going to look at the floor plan as well as the elevation. Then we would know that we have completed this chapter, and I would be confident that you would be able to approach this question also with confidence and answer without fear in terms of the exam. So I want you to practice on what we've done today. I want you to make sure that you apply all the techniques that I have been able to relate to you and use them now and again in terms of your practice work. All the best, boys and girls. Good night.